Hello, this is Mr. Stansbury. I'm going to take you through the notes on geometric mean. At the end of this, you should be able to say, I can identify and apply the relationships that exist when an altitude is drawn to the hypotenuse of a right triangle. Okay, so first things first. Here is our right triangle here. And to draw, we're going to draw the altitude up from the hypotenuse up here to the top, or actually probably the easier way is to start from the top here and then draw a line straight down, which makes a right angle down here. So we have now drawn an altitude to the hypotenuse of this right triangle. Okay, now when we do this, this actually makes some special angle relationships, actually some similarity relationships, because these triangles now are all we have actually three triangles. We got the small one here, the medium one here, and of course the big one that we started with. And there's going to be some special relationships. So I'm going to show you a little video here that kind of demonstrates how these angle relationships and side similarities appear. Okay. So here we have the same triangle that we just started with. So now I'm actually going to pull this small triangle over here and then rotate it around. So we're going to have the hypotenuse facing the right and the short side on the bottom. So we'll do the same thing here with this now medium triangle that was right here. Drag that over here so the hypotenuse is to the right and the short side is on the bottom. And then we can do the same thing with this the large triangle here. Now when we try to pull it over here, it's actually a mirror image, so I'm just going to take this thing over here and I'm going to reflect it right along this blue line right here. And now we have our three triangles here. Okay, so we started with the one big triangle, which was this, and then we pulled the small triangle and the medium triangle out of that. Okay, so let me show you some examples that will help us understand this a little bit better and see what the value is. All right, so let's do this. So here's again our original triangle, right? And here's our altitude, and pulled this triangle here is the small one, this is the medium one, and then the whole thing is the large triangle here. Okay, so taking an example here. So let's say if we gave these some values. So this piece here is 3, this is 9, here's x, y, and z. And what we're going to do is we're actually going to find x, y, and z. So in order to do that, what we want to do is we want to transfer this information here onto these three triangles. Okay, because these triangles, if I would have drawn them perfectly, then they would all be similar to each other. Okay, so if we'll notice here, here's the small triangle. So the red small side here, that's 3. And then the yellow side is x, and then the green is z. Okay, on the medium triangle, so the green is z no matter where that's at. The blue side here is y. So that makes this here is y as well. And then this shorter red side, which is this right here, is 9. And that would make this full red side, which is this hypotenuse of the large one, is going to be 9 plus 3. So that's going to be 12, right? Okay. And then this yellow side here is x. So now we've, from this here, pulled apart 3 different triangles, and we have actually written in all the, copied down all the data that we have from here over to this as well. So now we can figure out what x, y, and z are by setting up ourselves some ratios here. All right, so let's do that. Let's say, okay, if we want to find x, so we've got x here, and we have this 3 here as well. So we're going to, on the small triangle, let's do this. So for x, we're going to do the small triangle. We're going to take the hypotenuse to the short side, right? So the hypotenuse we'll say is x here, and then the short side is 3. Okay, so then we want to find another one that's got an x, or at least a couple of constants. And look, here's one that we've got another x and a constant. So on this one, again, remember we went from hypotenuse over short side. So hypotenuse on this one is 12. Short side on this one is x. Okay, so now the nice part about this is we've set up a ratio where we only have one variable, and that's the x's. Okay, so we can just cross multiply, set them equal to each other, and then away we go. So we got x times x, and that's going to equal 3 times 12, right? So that gives us x squared is equal to 36. So we take the square root of both of these, and we get that x is going to be 6. Okay, so we've now solved for x. Now what we're going to do is we're going to do the same idea, and we're going to solve for y. All right, so let's do y here. These are the two triangles that have y on them. So let's do this y. I don't want to go from hypotenuse to the short side here, the short leg, because that's two variables. So I want to do hypotenuse to long leg. So I'm going to do this here. So I've got hypotenuse is to long leg. And you could do long leg is to hypotenuse. It doesn't matter, right? As long as you're consistent with both these. So I'm going to do hypotenuse over long leg. So that's y over 9. And then here's the other one that includes y. So hypotenuse is 12. So it's hypotenuse over long leg. So that's going to be 12 over y. And then we do the same thing, cross multiply. Okay, so y times y is 9 times 12, which is 108. So that's, oops, I should be consistent here. So this is 12 times 9. So we get y squared is 108. So we square root both of those, and we get that y is, all right, so we're going to do the square root of 108. So we've got our square root button down here, square root 108. Well, it equals, it will simplify it as best it can. I always like decimals, so 10.39. So we normally will do these to the nearest hundredth. So we get 10.39. So y is 10.39. Okay, so now we know what the y value is. Okay, and again, remember the reason why we can do these is because these should all be proportional to each other, because this angle is the same as this angle here, right? Because that's where the red and blue meet. Okay, and then this angle here is going to be the same as this angle here, because that's where the red and the yellow meet, right? So again, we've got ourselves some nice proportional triangles here. All right, and then last one, z. Let's see, here's these two triangles here deal with z. So I'm going to start with, say, this small one here. And again, as long as you're consistent, it doesn't matter which one you start with. So I want to get my z, and then I want to have some kind of constant. So I'm going to do long leg over short leg. So long leg is z, over short leg is 3. And then here's the other one that has the z variable in it. So I'm going to do long leg is 9 over short leg is z. So we got 9 over z. Cross multiply, right? And we get z times z equals 9 times 3. So z squared is 27. So we take the square root of both of those, and we will figure out what z is, right? So we take square root 27, push equals, it'll simplify it, but let's get to the decimal, 5.196, so that rounds to 5.20, right? 5.20 is what our z is going to be. Okay? All right, that is how you do geometric mean. You just set these. The biggest thing you want to do is you want to take your triangle and you want to redraw your small, medium, and large triangle from that. And I can't stress enough how important it is to make sure that you get them all lined up facing the same, with the same orientation. It makes it much easier to do. Okay, so if you have any questions at all about this, please feel free to ask in class. Thanks.